Here today we see the topic increasing and decreasing function in the chapter application of derivative. First we see the increasing function. Okay, here first increasing function, let y is equal to f of x. Y is equal to f of x is a function on the interval a comma b. Here if the function y is said to be increasing, here the function y is said to be increasing. If x increases, then y also increases. If the value of x is increases, then the value of y is also increases. It is the increasing function. Now we see a graph. It is x-axis and y-axis. We see a curve y is equal to f of x in the interval a comma b. Okay, here it is a and it is b. Okay, here y is equal to f of x is a curve in the interval a comma b. The function y is equal to f of x, the function y is said to be increasing. If x increases, then the value of y is also increases. Then we take 2 points belongs to a and b. It is suppose x1 and it is x2. Okay, then here it is a x1, therefore coordinates of this point, it is x1 comma f of x1, and coordinate of this point it is x2 comma f of x2 are the coordinate. That means it is here, it is the curve. Okay, here then it is f of x1, and here it is f of x2. Okay, it is the value of y. Here x1, then it is f of x1. When x2, then it is f of x2. That means when the value of x are increases, the value of y are also increases. It is an increasing function. Okay, here we take 2 points x1 and x2 belongs to, it is a comma b. Then we have f of x1. Here first we have at point x1 it is f of x1, and at point x2 it is f of x2. Okay, here if x1 is less than x2, then we have f of x1 is less than f of x2. Here it is x1, okay, is less than x2. x1 is less than x2, that means x2 is greater than x1. Then we have f of x1 is less than f of x2. Here when x increases, the function is also increases. It is a increasing function. Now here first point it is x, then second point it is x plus s, third point x plus 2s. Here let it is suppose x1 is equal to x and x2 is equal to x plus h. Okay, here x is suppose x and it is x2 is x plus h. H is the difference between these 2 points. Therefore we can write here f of x1 is less than f of x2. That means f of x is less than f of x plus h. Here then we can write f of x plus h, it is a greater, f of x plus h minus f of x is greater than 0. Here याला इकडे घेतलं या साईडला. ओके, f of x या साईडला घेतलं, it is minus, therefore 0 it is less than, that means it is 0, it is a less than. Then f of x plus h minus f of x greater than 0. Now here h is a difference between them, therefore we can divide x plus h minus f of x upon h. is greater than 0. Okay. Here, then when h tends to 0, when h tends to 0, it is a f dash of x. When h tends to 0, it is f dash of x, and then it is f dash of x is greater than 0. F dash of x is greater than 0, then function is increasing. When the function is increasing, then f dash of x is equal to 0. Then the function increasing or decreasing. When the value of x is increasing, the value of y is also increases. It is a increasing function. Using derivative, you know that when the function is increasing, the f dash of x, the derivative of function is greater than 0. It is a increasing function, and it is called monotonically increasing or strictly increasing. Here it is monotonically or strictly increasing. Monotonically or strictly increasing function it is. Here f dash of x, here y is equal to f of x, then geometrical meaning of the derivative f dash of x. What is the f dash of x? F dash of x, it is a derivative, and derivative is a slope of tangent to the curve at any point. Now we can draw a tangent at any point in between a comma b. Okay, here we can draw a tangent to the curve y is equal to f of x at any point in the interval a comma b. Okay, here then the slope of any tangent in interval a comma b, slope of any tangent, here it is any tangent at any point. या point वर काढा कोणतेही, here another एक point it is. Then we can draw a tangent, okay, at a point. Okay, कोणताही point in the interval a comma b. Here कोणताही point घ्या, here या point वर एक tangent काढू. Then it is a tangent. Okay, here it is a tangent. Tangent makes angle, it is theta. Then f dash of x, at that point it is a slope of tangent. F dash of x at that point it is a slope of tangent, and then we know that by definition of slope, the line makes angle with positive direction of x-axis. Okay, it is a theta, and then the tangent of the angle made by the line with positive direction of x-axis, it is a slope of the line. That means f dash of x is the slope of the line, and also tan theta is a slope of the line, and this theta in between 0 and 90, that is theta is an acute angle. Theta is a acute angle, therefore tan theta is a greater than 0, and tan theta is greater than 0 means slope is greater than 0, and slope is greater than 0 means derivative is greater than 0. Here we can draw any tangent in between a comma b. We can draw any tangent in between a comma b makes acute angle with positive direction of x-axis. Here we can draw any tangent in between point a and b. We can draw any tangent to the curve at any point in the between a comma b, which makes the acute angle with positive direction of x-axis. That means here theta is an acute angle. It is theta is acute. Therefore slope of tangent is tan theta, and tan theta is greater than 0. That is the positive slope of acute angle, and value of the acute angle of the tan value of the acute angle, it is a greater than 0, and greater than 0 tan theta, it is a slope of line, and we know that the slope of line means f dash of x. Therefore f dash of x is greater than 0. Here it is a strictly increasing or monotonically increasing. Here we can draw any tangent to the curve at any point in the interval a comma b. The tangent makes acute angle with positive direction of x-axis. Okay, and therefore the slope of the line is greater than 0, and slope of line, that is line is a tangent, and then slope of the tangent, it is a derivative of the curve, that is the derivative of f of x, that is f of x at any point x, and it is x belongs to a comma b. Therefore when the function is increasing, f dash of x is greater than or equal to, it is greater than 0. It is a monotonically increasing. Okay, monotonically or strictly increasing, and when it is f dash of x is greater or equal to 0, it is a increasing, only increasing. Okay, then आता इथे सिंपल कन्सेप्ट, ज्या फंक्शनचा डेरिव्हेटिव्ह पॉझिटिव्ह येते दॅट इज ग्रेटर दॅन 0, ज्या फंक्शनचा डेरिव्हेटिव्ह पॉझिटिव्ह येते दॅट इज अ इन्क्रीजिंग फंक्शन, ज्या फंक्शनचा डेरिव्हेटिव्ह पॉझिटिव्ह येणार ते झालं तुमचं इन्क्रीजिंग फंक्शन. आणि सेम कन्सेप्ट डिक्रीजिंग फंक्शनचा. इन्क्रीजिंग फंक्शन काय, व्हेन द व्हॅल्यू ऑफ एक्स आर इन्क्रीजेस the value of functions are also increases, that is when value of x is increases y is also increases. And then the definition of decreasing function, the value of x is increases, then the value of y is decreases. Okay, here it is a increasing function, f dash of x equal to f dash of x greater than 0, it is strictly increasing or monotonically increasing, and f dash of x greater or equal to 0, it is only increasing function, f dash of x greater or equal to 0. Okay, here now we see the decreasing function. Okay, here decreasing function when x, now first we see the graph. The decreasing function here. Okay, it is b and it is a. Okay, now first it is a point x, that is x1, and then it is x2. Okay, then the coordinates of it is x1 comma f of x1, and it is coordinate x2 comma f of x2. Okay, now here it is f of x2 and it is f of x1. Okay, when x increases the value of function decreases, it is f of x1, when x1 it is x1, f of x1, and when x increases f of x is a decreases, that is value of y is decreases. That means when the value of x is increases, the value of y decreases, it is a decreasing function. Here when x is less than x2, it is here x1 is greater than and x2 is a less than, then we can write here it is a greater than, and now it is greater than 0, so it is less than 0. Now it is a less than 0. It is monotonically decreasing and it is only decreasing function. Okay, same concept, increasing function and decreasing function. If x increases then y increases, it is a increasing function. If x increases y decreases, it is a decreasing function. And then in increasing function f dash of x greater than 0, and in decreasing function f dash of x is a less than 0. Okay, here it is a less than 0, f dash of x less than 0. Now here we can draw a tangent at every point in a and b. Okay, at any point. Okay, we can draw a tangent. A function is differentiable, that means we can draw a tangent at every point in the interval a comma b, open interval a comma b. Now we can draw any tangent. Okay, any tangent, कोणताही point घ्या, here this point, okay, or any point we can draw a tangent. That means the tangent makes angle theta with positive direction of x-axis, and which is obtuse. Okay, which is obtuse angle. Okay, here theta is a obtuse angle, therefore tan theta in between pi by 2 to pi by 2, it is a negative, pi by 2 to pi. Tan theta in between pi by 2 to pi, it is a negative, and therefore theta is a obtuse angle, it is greater than 90 and 1 less than 180. Therefore it is a negative, which is less than 0, and therefore slope of the tangent is a less than 0. That means derivative of the function at that point is less than 0. Therefore the function is increasing, then derivative is positive, and function is decreasing, then derivative is negative. Simple concept. It is a monotonically or strictly decreasing function. Okay, here, and it is a only decreasing, f dash of x greater than or equal to 0. Okay, see the concept. Okay, here f of x is 0 is greater than, it is a 0 greater than. Here that means f dash of x less than 0. It is a decreasing function and it is a increasing function. Okay, here simple concept लक्षात राहू द्या. Derivative is a positive, then it is a increasing function, and if derivative is negative, derivative of any function it is negative, then it is a decreasing function. Okay, here is it increasing and decreasing. Now we see some examples on the increasing and decreasing functions. Here examples in the exercise 2.4. Okay, here first example. Test whether the following function is increasing or decreasing. Is increasing or decreasing. Here first example, it is f of x is equal to x cube minus 6x square plus 12x minus 16 for x belongs to real numbers. Okay. Now here given f of x is equal to x cube minus 6x square plus 12x minus 16 for x belongs to real numbers. Now we find the derivative of this function. Therefore f dash of x is equal to 3x square minus 12x and plus 12. Okay, 16 is the derivative 0. Now the function f of x is increasing or decreasing. If the derivative of function is negative, that is less than 0, then it is a decreasing function, and if the derivative of the function is greater than 0, then it is a increasing function. Okay, here now it is f dash of x, therefore we can write here 3 common निघतात, factor about it is a quadratic function. X square minus it is 6x plus 6, it is 4 and plus 4. Now it is 3 into x minus 2 whole square. Okay, it is a f dash of x. Now x belongs to, for x belongs to real number, okay, any real number, x minus 2 whole square, it is a square. Square is a always positive, that is a non-negative square. Okay, square of every real number, square of every real number is a non-negative. Therefore here f dash of x is greater than 0 for all x belongs to real number except x is equal to 2. Here except x equal to 2. Okay, that means x belongs to R when x is not equal to 2. When we take the value of x is 2, then it is 2 minus 2 0, it is a 0. That means it is a 0, neither increasing nor decreasing, then it is a monotonically or strictly increasing for x belongs to real number except x is equal to 2. Therefore, f of x is strictly or monotonically increasing function for x belongs to real number except x is equal to 2, and therefore here f dash of x greater or equal to 0 for all x belongs to real, that is f of x is increasing for x belongs to real number. Okay, here when x is equal to 2, then f dash of x equal to 0, and when x is equal to except x is equal to 2, it is a greater than 0. Therefore, f of x is increasing function for all x belongs to real numbers. Okay, now we see the next example. F of x is equal to 2 minus 3x plus 3x square minus x cube when x belongs to real numbers. Now, same concept, given f of x is equal to 2 minus 3x plus 3x square minus x cube. Okay, therefore find derivative f dash of x. Okay, here f dash of x is equal to, it is a 0 minus 3 plus 6x and minus 3x square. Therefore, take minus 3 common, minus 3 into 1 minus x, it is 2x and plus x square here, and therefore f dash of x is equal to minus 3 into x minus 1 whole square. Okay, now for any value f dash of x is less than 0, because it is negative and it is always non-negative. Non-negative into negative, it is negative. For any value it is a less than 0 for x belongs to real number except x is equal to 1. That means f dash of x is less than 0 for x belongs to R, x belongs to all real numbers when x is not equal to 1. When x is equal to 1, it is a 0. Okay, non-negative. That is f of x is monotonically decreasing function for x belongs to R except x is equal to 1, and f dash of x is less or equal to 0 for all x belongs to real number. Okay, here only for x belongs to real, all real numbers including 1, it is for all real numbers it is a less than 0, but x is equal to 1, it is a 0. Okay, therefore f of x is decreasing for x belongs to real number. Okay, here it is a decreasing. Now it is derivative is negative, therefore it is a decreasing function. When derivative is positive, then it is a increasing function. Now next example. f of x is equal to x minus 1 by x for all x belongs to real number except 0. Now given f of x is equal to x minus 1 by x for all x belongs to real number except x is equal to x is not equal to 0 here. All real number except x equal to 0. Therefore f dash of x, it is 1 and 1 by x are derivative minus 1 by x square. It is plus 1 by x square. And here for all real number it is a positive. Therefore this term is positive and 1 plus positive it is a positive. Therefore it is a greater than 0. Okay. Therefore f dash of x greater than 0 for all x belongs to R when x is not equal to 0. Therefore f of x is increasing for x belongs to R. F of x is increasing for x belongs to R. It is f dash of x greater than 0. It is a positive when x is not equal to 0. Okay. It is a increasing function. Then increasing and decreasing concept एकच लक्षात राहू द्या. Derivative less than 0 it is a decreasing and derivative greater than 0 it is a increasing. Derivative positive आला तर increasing and derivative negative आला तर decreasing. आपण हाच कन्सेप्ट याच्या आधी रिलेटेड रेट्स रेट ऑफ चेंज मध्ये पाहिलं होतं. रेट ऑफ डिक्रीजेस जेव्हा घेत होतो तेव्हा रेट ऑफ चेंज निगेटिव्ह लिहित होतो आणि रेट ऑफ चेंज एवढंच दिलेलं आहे. रेट ऑफ इन्क्रीजेस दिलेले तेव्हा ते ॲज इट इज पॉझिटिव्ह. दॅट इज रेट ऑफ चेंज पॉझिटिव्ह असला रेट ऑफ चेंज मीन्स डेरिव्हेटिव्ह पॉझिटिव्ह असला इन्क्रीजिंग फंक्शन, डेरिव्हेटिव्ह निगेटिव्ह असला इट इज डिक्रीजिंग फंक्शन. ओके. आता इन्क्रीजिंग आणि डिक्रीजिंग याचेच प्रॉब्लेम आणखीन नेक्स्ट लेक्चरमध्ये पाहू आपण.